Hello, welcome to the course on cloud computing today. We will have our first lecture. As you might have seen the broad overview of the course. So in this particular modules, that is Journey to the Cloud Computing. Myself Sapna Raghuvanshi, Assistant Professor, Department of Computer Engineering, R.C. Patel Institute of Technology, Shift. So, this module focuses on the business drivers, definitions, essential characteristics, and phases of journey to the cloud. So, with all the interest of surrounding cloud, it is helpful to understand what is driving this need to change. Each IT organization has its own unique drivers, but generally fall into some general categories, that is cost, availability, time to time market, etc. There are pressure outside the IT from the organization's highest level executives who are looking for more flexible, doing more with best cost, and using information as a competitive advantage. IT organizations want to respond by transforming IT into something with greater businesses agility. The IT challenges listed below have made organizations think about the cloud computing model to provide better service to their customers. So first is a IT challenges, that is globalization. It must meet the business needs to serve customers worldwide round the clock 24 by 7 hours. So aging data centers, migration, upgrading technology to replace old technology. Next, storage growth, that is explosion of storage consumption and use. Application explosion, new applications need to be deployed and their use may scale rapidly. The current data center infrastructures are not planned to accommodate for such rapid growth. Next is cost of ownership. Due to increasing business demand, the cost of buying new equipments, power, cooling, support, licenses, etc. increases the total cost of ownership. Next is acquisition. When companies are acquired, the IT infrastructure of the acquired company and the acquiring company are often different. These differences in the IT infrastructure demand significant effort to make them interoperable. So, for organizations to be competitive in today's fast paced, online, and highly interconnected global economy, they must be agile, flexible, and able to respond rapidly on the changing market conditions. Cloud, a next generation style of computing, provides highly scalable and flexible computing that is available on demand. So cloud computing empowers self-services, requesting through a full automated request fulfillment process in the background. Cloud computing promises real cost saving and agility to organization. So through cloud computing, an organization can rapidly deploy applications where the underlying technological components can scale up and scale down. So based on the business requirements. So building a cloud infrastructure. So infrastructure should meet essential cloud characteristics. So characteristics to support cloud services. It can be built using a shared pool of computing resources such as compute, storage, and network. The infrastructure should be flexible to meet the rapid changing demands of its consumers and allow them to provision resources on demand over network. The infrastructure should also enable monitoring, control, and optimization of resource uses. So, building a cloud infrastructure is a phased approach. The journey begins with understanding the existing physical infrastructure, its elements, and processes. The next step is to focus on aggregating the existing infrastructure resources using virtualization technologies. These resource pools facilitate centralized management of resources and enables faster resource provisioning. The next step is to deploy service management tools that enables automation of processes and management to minimize human intervention. The service management tools also include measured services, which enables consumption-based metering. With the service management in place, on-demand provisioning of IT resources become more dynamic and allow IT to be delivered as a service. So although virtualization is a key step toward building cloud, it is possible to use highly automated physical infrastructure to provide cloud services. However, it may not be optimized. So these phases are explained in the next few slides. So understand existing infrastructure, that is classical data center. So classical data center is a facility that enables IT resources to process data. The core elements of classical data center are compute, storage, network, application, and database management system. So one by one, see these are facilities. First is application. Application is a computer program that provides the logic for computing operations. Application may use a database management system which uses operating system services to perform store retrieve operations on storage devices. Next is database management system provides a structured way to store data in logically organized tables that are interrelated. A DBMS optimizes the storage and retrieval of data. Compute is a resource that runs application with the help of underlying computing components. Storage is a resource that stores data persistently for subsequent use. Network. Network is the data path that facilitates communication between compute system or between compute system and storage. So these IT resources are typically viewed and managed as separate entities. But all these elements must work together to address data processing requirements, other elements of classical data center, and are power supplies and environmental controls such as air conditioning and fire suppression. So journey to the cloud phase, a phased approach. Here is virtualization abstracts physical resources such as compute, storage, and network to a function as a logical resources. It creates a abstraction layer to hide the physical characteristics of resources from user. For example, in compute system virtualization, a physical machine appears as multiple logical machines, that is virtual machines, each running an operating system concurrently. So virtual data center is a data center in which compute, storage, network, and or applications are virtualized. Computer virtualization enables running multiple operating systems concurrently on a compute system. This improves compute system utilization. So storage virtualization provides a logical view of storage and presents it to the compute system. In network virtualization, multiple logical networks are created on a physical network. Each of these virtualization technologies is explained in detail in the forthcoming modules. So by consolidating IT resources using virtualization techniques, and organizations can optimize their infrastructure utilization. By improving the utilization of IT assets, organization can reduce the cost associated with purchasing new hardware. They also reduce space and energy cost associated with maintaining the resources. Moreover, less people are required to administer these resources, which further lower the cost. So virtual resources are created using software that enables fast deployment compared to deploying physical resources. So virtualization increases flexibility by allowing to create and reclaim the logical resources based on business requirements. Key points covered in this model are IT challenges and business drivers for cloud computing introduction phase for building cloud infrastructure, the phases in journey of classical data center to cloud.